After we have asked our question, created a hypothesis, and planned our experiment, we need to write a prediction about the data that we expect to collect that is going to support our hypothesis. If you need a review on how we write a hypothesis or how we design an experiment, you'll want to go back to Brightspace and look at those two previous videos. So as a quick reminder, a hypothesis is an educated explanation based on your background knowledge. It's going to be tailored for your specific question to answer that causal question. A good hypothesis is going to be testable and lead to predictable data. Now, just because we can think about what data we might need doesn't mean we're going to support the hypothesis, but that is our goal. Our goal is to support our hypothesis. And so we are going to design an experiment to collect data that is hopefully going to support it. And we are going to predict the data that we need in order to support it. So we are going to write our hypothesis, and then we are going to write a statement that predicts that data that we're going to need. So we use our hypothesis to predict the data that is going to support that hypothesis. So if we ask the question, what causes leaves to fall in autumn? We're going to form a hypothesis or a cause for those leaves falling in autumn. Now, if you remember from a previous video earlier in the lecture, we said that shorter days cause leaves to fall. And from our video on designing an experiment, we know that the independent variable is going to be our cause. So our hypothesis is going to state our independent variable. Our prediction is going to state the effect of that independent variable. In other words, it is going to state the data that we expect to gather, because our dependent variable is our data. So if we want to support that shorter days cause more leaves to fall, then our prediction should say something about short days or day length and the amount of leaves, because that's what our experiment should have been designed to check. The amount of leaves and a greater percentage of leaves falling as the days get shorter. Our prediction is written in a very specific format. We sometimes call it an if-then statement because it is written in an if hypothesis, then prediction format. So when you write this, you are going to take your entire hypothesis as is and just plop it right in the beginning. If my whole hypothesis. Do nothing else with it. Don't insert anything in between it. Don't add anything to it. A good hypothesis doesn't need that because a good hypothesis doesn't contain your data. And then you're going to insert the specific effect or the prediction. So if my hypothesis is correct or supported, then this is the data that's going to show it. So another way to think of this is if your general cause, day length, then your specific data, more leaves. So if we write this all out, we can see our question, what causes leaves to fall in autumn? Hypothesis, the amount of daylight causes our leaves to fall. Now our textbook example says the shorter amount of daylight causes leaves to fall. Now, I like to teach my students to keep the hypotheses a little bit more general because it causes less confusion with students and it allows them to more easily distinguish between the hypothesis and the prediction. So I'm not saying that using the shorter amount of daylight causes leaves to fall, but what I am saying is that students have less trouble when they make their hypothesis a little bit more broad. So I'm going to ask you to use the amount of daylight causes leaves to fall. So then we write our if-then prediction statement. So if amount of daylight causes leaves to fall, then our data statement. More leaves will fall. We can measure that. That's measurable. When exposed to progressively shorter days. That is our independent variable and our dependent variable. Now our independent variable is also in that hypothesis. Amount of daylight. That is what we're using as our controlled variable in this particular sense. We can't control the sunlight, but we can measure it at different intervals. So if our hypothesis, then our data. If amount of daylight causes more leaves to fall, then more leaves will fall when there are shorter days. We have summarized our hypothesis and our entire experiment in this prediction statement. From here, we're going to go on to actually perform our experiment based on our controls and setup that we learned about previously.